Australian standards and how they relate to, AS 1100 and how it relates to technical drawings, especially in the context of the HSC engineering studies. So what I'm going to talk about first is I have an hour's worth of videos that you can watch already. Whoops, that's not the button I wanted. I wanted this button. So I'm going to go, I don't want to double over too much of what I've said there, but this will be a summary of those, and it will also, I'll also use some references a little bit more than I maybe did last time, and just to really confirm that we're, covering everything we need to talk about. Always good to see people saying hello on the chat, that way I know that someone can see the things and that we'll open that, and that wasn't what I wanted. I wanted downloads drawings AS 1100. Okay, so this document is where this is where I'm going to start. Now, everything I put in exams will usually be something from this document or from a past HSC when you're in year 12, right? So for the moment, the drawings that I use will come from the document that I give you. Now, I might update, I actually intend on updating this document, but for now, this is the document that when I write like a prelim test for the end of the term, this is probably what we're going to, there's going to be a drawing and the drawing's going to be based on this. Okay, so the thing is, it starts off with what are the syllabus dot points. These all relate to year 12s, but it's important we understand what's going on here. So, for instance, we need to know what an assembly drawing is. We need to know dimensioning. We need to know that we should be able to draw freehand pictorial drawings. Now, freehand doesn't mean you're not, you have to, freehand means you can use a ruler, but you don't have to use a ruler. Okay, so we can use graphical mechanics. That's where we draw lines to solve questions. We've already seen that with our 3-4 method. We need to learn about computer-aided drawing, or CAD, which we've already, that's what I've been setting for this current set of students, a lot of homework previously. Okay, so we need to be able to produce orthogonal assembly drawings, applying the Australian standard, AS 1100. We need to be able to produce freehand pictorial drawings, which I've already done that a fair bit with you guys. Graphical methods were already said, and describe and or use software to solve problems. Okay, in public transport, we have very similar things. Nothing that really looks new there. Okay, in aeronautical engineering, we have to learn about developments and transition pieces. This is hard. If you look at my stream though, you'll be able to see that I've already done. I did that on Zoom. I'm going to do a new one. Don't worry, on stream. So for you guys, by the time you're in year 12, that will be ready for you. But that's what I'm currently doing with year 12s now. Construct quality graphical solutions. Okay, so that means just solving HSC questions for me would be sufficient. Now we need to use appropriate software to produce pictorial drawings. So that means you have to use software to produce a 3D or perspective, so an isometric or a perspective drawing. Okay, so in telecommunications, nothing really new there. Justify computer graphics. Okay, so before we move on, we'll talk about why do we use computers, right? So the first thing to say is that when I was a civil engineer, that my company didn't let engineers do their own drafting. I did my own drafting once or twice, and they really didn't like it, because the thing is, the time that it would take me to do it, their argument is, even with revisions, even with me having to draw it out on a piece of paper first, they said that it's just cheaper for them to pay a specialist who, the specialist is also being charged at a lower rate than an engineer, because they haven't done a 4-year degree. That it's just cheaper to have a specialist who does this all day, every day, to do the drawings, because they're not going to make mistakes. They're not going to have to go back. And the thing is, even if you think it looks good, the problem is that you might find that the client comes back 6 months later and says, hey, this drawing is wonky, right? There's things here that shouldn't be in professional standard drawings. And I can understand that argument, because effectively I was a hobbyist CAD operator, whereas, you know, professional CAD operators are going to do a better job than me. Okay, moving on. So the next thing we're going to look at is a big part of HSC questions is drawing threaded sections. Now that requires a couple of concepts we need to understand. The first thing is we need to know that this end of a bolt is called a thread, right? And this is really important that we can dimension that properly. When we draw a threaded section, we don't draw it as a zigzaggy line. Instead, we have a different standard that we use to draw nuts and bolts. So that's really important. Then there's the concept of what is a section, right? So sections are fairly important. We use sections to show things that are cut in half. Now, we never section bolts, along with a couple of other things that we never section. Now, the other thing is that this standard is, there's a standard for nuts and bolts, so that they won't give you the dimensions of the bolt. They'll just label the bolt as being a M13 bolt or an M65 bolt or something like that. That'd be a very big bolt. But once they give you that dimension, they just expect you to be able to determine the size of the head of the bolt, the size of the nuts, the size of this distance here. All of those things they expect you to know. So because they're standardized, right? So this is showing an M20 bolt, which is actually, there's even more detail on that. This is drawing an M20 fine 2 bolt. Anyway, we'll worry about these things later. This is how they draw nuts. I have some mnemonics to help us to remember that, but we're not really at that point yet. Okay. Just in case I don't mention it, so I've got my YouTube channel here. One of my very first videos way back when, unfortunately the audio is a bit quiet, is me going through nuts and bolts, right? Just specifically talking about what nuts and bolts, like how we don't draw the zigzag and what we draw instead. It's not great, but it will do, right? So that's what I've got there. Okay. Moving through the drawing, the next thing we're going to talk about, so we mentioned sections, right? So sections are when we cut things in half. Now, if you watched my stream last time, you'll have seen that I used an example which I thought was pretty reasonable. Oh, I wonder where those windows went. I bet you I didn't save that. I have to go through my history and find it again. But if you have a... Okay, if I told you that we wanted to manufacture an apple and I just showed you the outside of the apple, well, it's not going to give the manufacturer nearly as much information. Now, I could draw some hidden detail. We've talked about hidden detail. Hidden detail is where you draw the dotted lines. But you're not going to have nearly as much information as if you show it in section, where you just show the thing cut in half. And that's a really useful tool, right? So what we do is with the area that is actually being cut, we have a way of showing that, which is we hatch it. Okay, so if I have a capsicum, right? In this case, we have a hollow. There's nothing here, right? There's nothing here, but there is something here. Right? So if I had a front view and a section front view, right, that would be what we're talking about. Now, when we do a section view, so we have this hollow, right? We have this hollow, and you can see here that the area that's actually being cut through, we draw these diagonal lines to show that the thing has actually been cut through. Now, what is interesting is occasionally we get this here, we get pith, right? Now, I don't know how much capsicum cooking you guys do, but I'm going to assume that you understand what pith is. Pith is where we get this small, well, kind of like what we'd call in engineering a web, right, or a stiffener that joins to the center, but it's not solid. This red area is solid. This white area, it's only solid, but only for a section, right? Only for a millimeter or two, and then it goes back to being hollow. So that would be, if we were to section this in the same way, if we were to section this pith, as being, well, we're cutting through it. Yes, we are cutting through the pith, but we can see here we have this web, right? This web is here, but it's not solid. It's just a web, it's just a stiffener. Now, the Australian standard does specify that you can section these if you want, but whenever we have it, you should, if you do section it, you should do it as thick double lines. But way back, one of the first GIFs I made, which I never bother using anymore, and it'll probably take too long for me to find. I'd have to go way back and find that GIF. But I had a picture of Taylor Swift saying "like ever," right? Don't ever section webs like ever, right? Don't do it, right? Just like Taylor should never get back with those boys who break her heart. Just don't do it. Right here we have another web, and we're showing that it's not hatched. Now we have a couple of line types we talk about here. We talk about center lines. How we show a section, right, is we often show with these thick dark lines on the edge and an arrow pointing in the direction that we want to look at. And what we have here, in this case, the web is being hatched because it's effectively solid in the direction that we're looking at. It continues all the way through. But like I said, if in doubt, just don't section, right? You're never going to lose a mark for sectioning a web in the HSC, right? Don't do it like ever. Okay, so here we have another drawing. And what's interesting here is that if we're going to section, it doesn't show where our section line is. But if they said that they want us to draw a sectional front view, what they've done now is they've said, okay, we've drilled these holes in the top. But do you see how the section, if we cut this in half, we don't actually go through the hole? And if we go through the hole, what we can do is we could show it as a hidden detail, right? But we don't like to do that. The best solution is, even though we don't go through the hole, we just draw it as though we're going through the hole, as though the section goes through that hole. That is the expectation. And the point is, even though you're in year 11, and even though I give this to you right at the start of year 11, I put these documents here because they're so important, because this is the key to what we're going to be marking when we get to the HSC level, right? This is what we're going to be looking at. This is the stuff that's important. Now, then I get back to year 11 stuff, right? Where I gave this to you maybe in the first week of year 11, is I got you to line up which of these are, which isometric matches up with this. So this one here matches up with that by the look of it. And you can see in this case, we're showing hidden detail to line up A and 10. Pretty sure that A and 10 match. Because in this case, the hidden detail provides a little bit of extra detail, helps us to know what's going on. Now, these sorts of things are good questions for me to give you in a year 11 preliminary exam. These are questions that I have made you draw on AutoCAD, so now we should be really familiar with these questions. Okay, moving on. Now we're getting to the Australian... so here we have these bolt dimensions. Now, I talked about these before. These bolt dimensions, at the back of the document here, I have the Australian standard, or I've got pages out of the Australian standard. I do have the full Australian standard somewhere if you really want them. But they specify what dimensions these should be. But the thing is, we can use structural and non-structural bolts. The HSC has just decided we're always going to use the non-structural value. So you don't need to memorize both, you just need to memorize the non-structural value. Now, I don't really like memorizing these. These are things that I kind of resent, and it took me maybe 5 years to really get these under my belt. I now have some mnemonics that kind of help me to remember. I'll give that to you now just in case I never mention it to you later, which is, I remember that head at 7 o'clock, nut at 8 o'clock, and then 9 o'clock is the distance from here to here or here to here, right? So 7, 8, 9, right? Why was 6 afraid of 7? Because 7, 8, 9. 7 for 7 head, 8 nut, 9 is this. Okay, that's how many tenths of the diameter each of these things are. That's what helps me to remember it. This distance here you will remember because we'll talk about that a lot. Okay, so if you did graphics, you might be familiar with some of these concepts, right? Because you will have already drawn this drawing. And so what we can see here in this drawing is that we don't section, even though we're cutting through the nut, right? We're cutting through the head of the bolt, I should say. That should be 7, head at 7. I have in the past said, hey, these are things I think we should change, but that should be 7 because that's the head at 7. Anyway, so there's some details like this stuff here. That's hard. We're going to learn that in year 12. But for the moment, we're going to say, because there's two separate materials that are being bolted together, to show that it's two separate materials, we have the lines going in different directions to show that this is a different material to that. Okay, then I've got a whole bunch of different drawings for us to do. These are just practice drawings. I think I did set these for work maybe a term ago. Okay, and then we're going to get to assembly drawings. So these are assembly drawings from different HSCs and sometimes from trials. And so this is a HSC. This is, I guess, the 2012 paper. And this is the 2014 paper. Okay, these are developments. We talked about how this is stuff I'm doing with Year 12s now. You don't need to worry about that. So there's some things, some drawing standards that we need to learn about, things like tolerances. So tolerances is sometimes we're going to say that we don't know the dimension, or we can never design something, we can never manufacture something that's perfectly 95 millimeters. It could only ever be 95 millimeters, like so 95.000000001 millimeter, right? Eventually we're getting to the level of atoms where we can never get perfectly to this, platonic ideal of 65 millimeters. So what we're saying is it's 65 millimeters, give or take 0.05 of a millimeter, right? So we're being very accurate, right? We're way more accurate than half a millimeter. We're down to a 5 out of 100 millimeters, right? So that's a 20th of a millimeter. That's how accurate we need to be, right? That's the sort of stuff you need, precision instruments to measure. You can't measure that with a ruler. Okay, this is a question about computers. So it's just pointing out that they can sometimes and do occasionally ask questions about things like AutoCAD. I don't like these questions because they're very AutoCAD centric, and although we're using AutoCAD, I don't like that they're AutoCAD centric. And the other consideration is that these things change. They change really regularly, like they change quite frequently. Like I said, we're going to look at that again later. So sometimes we're asked to not section a full thing. We're asked to do a half sectional view. And in a half sectional view, the top half, so what we've got is an apple. I don't know if we can find an apple in half sectional view. Apple half sectional view. What am I in Bing? I am in Bing. I'll be impressed if Bing finds this. No. But this picture will help us. So a half sectional view imagines that we only cut away 1/4. So what we have is only 1/2 of the view is in section. So we're going to see the object as it is on one view, and a half sectional view, or this 1/2 of the thing is going to be shown in section. I'll just see if we can find an apple just by actually searching Google, because half sectional view. That's a half sectional view. That answers the question. Unfortunately, it's not the half that I'd like. The idea is when something has an axis of symmetry, we really want the half sectional view to go through the axis of symmetry. We do again have another example of a half sectional view. So not great, but sometimes demonstrating something that's wrong is good too. So a half sectional view is we're cutting away half of the apple and showing 1/2 of the apple. Like I said, I would much rather that they show the sectional view with down the axis of symmetry. That's the typical way of doing it. But I can live with it. Okay, so this is an object shown in half sectional view. So we can see that there's this circle at the front of the object, but when we cut it in half, what we can see is the circle, which is much smaller at the back of the object. So that's a half sectional view. Yeah, we're going to look at that. That's already in there. Okay, so here we have another. Okay, so we have another object here, pretty simple object in half sectional view. The section can move through these weird lines, right? The cutting plane can move through a weird line just so we're showing all the interesting stuff. That's something we can do as well. That's called an offset section. Okay, I'll include that as a link. Where are we going? Got to go back to Edge. Okay. We've got some more drawings. Okay, so here they want us to draw a half sectional view. And there's some, if you watched my stream yesterday, I talked about spot facing. So spot facing is when we show that there's a circle within a circle, but the first circle doesn't go all the way down, right? So that's a way that we can specify. So we can have a 20 millimeter hole that goes all the way through and a 40 millimeter hole that only goes down 12 millimeters. That's spot facing. So we learn about that later, but I just want to try and get us established with why we have this document, or what's in the document. Here we just have a whole bunch of HSC questions and past trial questions. These pages here I don't really like. They do explain what a spot face and that was a counterboard, not a spot facing. It's the same concept but in reverse. So a spot facing is like we have this raised circle here. Anyway, there's a counterball there. Yeah. Okay. Some drawing standards, and then just more and more tasks. Okay, so now that we've gone through what's in this document, okay, in terms of practice questions, we've got a couple of documents that are important. So let's have a look at what we're going to do now. Is we're going to go here. So the fundamentals that we should all be very familiar with at this point, and just check on one double speed, is you should all be familiar with, there's different kinds of pictorial drawings. There's perspective, isometric, and oblique. The reason we like isometric drawings so much is because they can draw circles in two directions, whereas with oblique, you can't really do that. It's very difficult to draw that. Perspective are just hard to draw all the time, but with Google SketchUp, it has become a lot easier than it used to be. Okay, so that's what we're looking at in this section, right? Now, if you want to go through that, you can go through that in greater detail later. Here, what I'm talking about is matching isometric drawings to orthogonal drawings, which you've seen already. Now, what I just had it up there a second ago is I talk about how you can buy templates to draw those circles. Now we have, I think we bought those templates. I haven't laser cut them though. Okay, and so set squares, I now provide set squares as part of like fees, but I do try and take them back. So like that's why we label them, just so that way if you have to do an exam, you can draw these isometric circles by hand if you want, and I have a video that talks about how you draw those by hand. Okay, what I'm talking about here is third angle projection. So third angle projection, again, if you watched my stream yesterday, I talked about this a little bit as well. So in Australia, we use third angle projection, which means that we draw this target, then the flag, not the flag, then the target. That's the symbol for third angle. Target starts with a T, but the key is that the top view is on top in Australia, right? The top view is drawn on top of the front view, not the other way around, right? In France, it's not how they draw it. They draw everything from the top view and they roll out. You don't need to worry about first angle projection. You just need to worry about how we produce these. Now, if you see down there, they show a box, and I've made one of those in class out of Perspex so that I can demonstrate how we actually make these shapes and draw pictures. I think I did that with you guys, but I can't remember if I've done that with, and that's only would be with this current class. The really important thing is that when we draw these drawings, that everything needs to line up. The top here needs to line up with the top here, right? And if we bring this out at 45 degrees, this object should be exactly the same distance away. But really the key is that this lines up with this, and this lines up with this. Everything needs to line up with the front view. If you don't do that, you're going to lose a mark. Okay, you're allowed to draw construction lines. Yeah, so this object that I'm circling here, I made one of those. If you want to, when we go back to class, you can let me know. But the idea is you can draw, imagine you're drawing on a piece of Perspex, and then you fold the Perspex out, and then you get your shape. Okay, so that's what we're looking at here. Okay. At this point, we're now going to talk about some of the standards that we need to worry about. So we have line types and how we dimension things like circles, right? And for that, we're going to go back to our document. I think that gets us through the rest of this video. So just with the document I had open. So what we have here is there's different line types that need to be used when we're referring to, when we're drawing these drawings. So probably the best way to look at this is with an actual example, but so we have thick lines, what we draw by default. If we're drawing hidden detail, we draw thin dash lines. If we're drawing dimension lines, they should be thin lines. And we draw something else called center lines. And so center lines show us the center of, they show symmetry, right? So they usually rotational symmetry. So things like cylinders and spheres. And we can also, if we have something that's mostly cylindrical but has some square sections, there's some rules for that and how we show that as well. Okay, before we go to, well, okay, this drawing here demonstrates all of those line types. So here we can see it's in third angle projection because our front view is in the front, and then we have our side view. Now the side view is as though it looks in. So if we're seeing that this is close to the front, this is at the back. That's what we mean when we look at the front view. If you draw those lines at 45 degrees, you shouldn't have any problems, but occasionally it is possible that people draw things in the wrong spots. Okay, so we draw the outside of the object with a thick dark line. Then we've got these holes that are going through the object, right? We have some things that are cutting through the object. Now this, so I would have thought maybe that this was sticking out until I look at the drawing and see, no, this doorway, this arch shape is actually pushed in, right? It's like a spot facing. But then we have these things here are like a step that are coming out of the drawing, right? So they're a step that's coming out, but this here is not a hollow, but it's thinner at this location. Then we have a hole coming all the way through. Now to show those things, to show that this is a cylinder, right? To show that this is a cylindrical hole and not say a square hole in this view, what we do is we put a center line. Now the center lines also help us to locate, because when we drill a hole, we need to know where the center of the hole is to drill it. So we show that with center lines, and you can see the center lines here. The last type of line we saw is thin light lines, and these are these three thin light lines which project to the object. They shouldn't touch. So you can see here it says 1 millimeter off the drawing, and that I like to have my extended lines go 2 millimeters off the drawing. The arrowheads are specified as 3 millimeters long and 1 millimeter wide, right? So those sorts of things are specified, and we can use this drawing standard here. Now, when we want to dimension circles, there's a couple of different ways that we can dimension circles. We tend not to use radiuses because we never have a drill bit that's measured by radiuses. And generally, like if we have a pipe, we don't get pipes dimensioned by radiuses. Dimensions are what we use. This is why whenever we talk about areas, I tell you should always use pi d squared on 4, not pi r squared. I know, because I was a student once, I know that everyone wants to use pi r squared, but let me tell you, eventually you realize that there's no radiuses in engineering, except for these radiuses, which, I'm trying to do that for comedic effect. I'm not sure if that landed, but you get the idea. So the idea is sometimes we do have rounded edges, and in that case we might specify a radius. And when we specify a radius, we specify it with the letter R, and we draw a line that goes, this line should go towards the center of our center line, and then it should, these lines here, these leader lines, should then go at 45 degrees. You can specify it like that. I don't like that. I wouldn't do that. We can do the same thing with diameters, but with diameters we use the diameter symbol, which is this circle with a line through it. Some people use that same symbol to write the number 0, and it's also a Danish letter. So it's a bit confusing there, but that's the symbol we use for diameters. 3 different ways of specifying diameters. We can just specify it like we do any other object. We can draw it with a leader line, or we can use, I like this method, which is we draw across the object through the center, and then the line continues out. You can just label in here 30 degrees. I'm okay with that as well. So that brings me to our Facebook page. Okay, we can worry about that later. What did I want? Yeah, well, this probably do. Okay, so I'll go through this and say that in this drawing here, this is a really good question. I use this question a lot. It says, which of these is correct? Right now, it says, well, how do we know that we're not in France? Well, this symbol here with the target, then the flag, remember the flag is always drawn as a less than sign, is a symbol that says we're in third angle projection. Where if they've specified the front view, that means the top view has to be on top of the front view, right? In Australia, third angle means top on top, right? So what we want is this one here, A, because it's got this French flag, and the French flag is, if we're looking from this direction, if this is front, then that means we're going to have 1 line, 2 lines, 3 lines, 4 lines, which you can see here if we go from the front, 1 line, 2 lines, 3 lines, 4 lines, right? From the side, when we turn this around and look, if we were looking from this side, what will we see? If we look at this side, we'll see 3 lines like a, did I say this was a French flag? Sorry, like a German flag, and this one's a French flag. Okay, if we look over on this side, we'll just see a rectangle because there's nothing there. It's just blank, right? This one's wrong because the top view is not indirectly in line. Well, okay, this is wrong here, but also the top view needs to be directly above. So C is wrong straight away because the top view needs to be aligned above the front view. This is wrong because it has, well, these are both wrong because they're French flags and not German flags like they should be. Okay, so this is a simple object, and I'm showing how we draw it. So this is our object looked at the viewed from the front. We have this object physically in our room, in the classroom. Remember that the top and front views need to be aligned. The side and front views are aligned. Place the objects in the correct spot. So this is the view. This is the view as looked at from this direction. Also, sometimes we might say, I think I maybe gave this in a paper. I said, okay, draw this object, but if you don't draw it from the correct dimension, if I draw an arrow and I say draw from this side, draw from angle B, and you draw it over here, you're going to lose a mark. Okay, so we're going to talk about line types. We mentioned when we said thin dark lines and thick dark lines. So thin dark lines should be drawn with a sharpened HB pencil. What you usually start with is you're supposed to draw, before you get started, you're supposed to do sort of your practice drawing using a 2H pencil, and then you don't rub it out, you don't erase it. For your thick dark lines, you're then supposed to use a HB mechanical pencil, or a pacer, which is what it used to be called when I was a kid, and you're supposed to hold it perpendicular to make sure that you're always getting a line that is actually 45 degrees. If you hold it on its side, you're going to get a chiseled edge, and you're not going to get 0.5. You're going to get a smaller line, and then eventually you're going to get a thicker line. So I don't talk here about how to get your thin dark lines. Your thin dark lines on this drawing are supposed to be done with a sharpened HB pencil, but the reality is I don't think any of that matters anymore. I think the HSC has moved along, and even when I did the HSC, I didn't use a sharpened HB pencil. I just used my pacer, and I just held it on the side, and I just ran over the line lightly. The fact is that there's different shorthand systems that are called light and dark, and that's because you can get a darker line with a pencil just by pressing harder. That's not true of a pen, right? With a pencil, you can get a lighter and darker line just by pressing harder. Anyone who's interested in learning Pitman shorthand, let me know. Pitman's an interesting shorthand. If you do this, there's some lessons on how to do Pitman shorthand. Okay, so just showing some labeling, a little bit more detail. So this is how once I've drawn the drawing, I've then gone over it in a darker pencil. So this is what I'm doing in construction, and then I'm firming it up with so these I'm drawing as my construction lines, they're in blue, then I'm going over it with black, and then just to show you that they should be thick dark lines, so I can really see the difference between my views. We draw a 45-degree line and extend out. If you're not sure what that means, have a look at some of my other videos where I use that method to produce the drawings. In terms of the text, headings, titles are 5 millimeters. If you can see this drawing here. Titles are 5 millimeters. Headings should be 3.5. Dimensions are supposed to be 2.5. That's specified in the Australian standard. Okay, so okay, I don't have the circle there. I'll have to figure that out. Things to help us remember with threads we'll worry about later. Okay, so I mentioned before that we specified fine thread. If you watch my YouTube video, it will talk about this in greater detail. This is the YouTube video down here. But a fine thread has more threads on it, whereas a coarser thread has less. Now, we specify these different ways. So I help us to remember that when we need to calculate the D-min is calculated differently if we've got a fine. So this is Ryan Gosling, he's pretty fine. And this is Clive Palmer. He was a student suggestion for someone who, he's a bit coarse in his language perhaps. Okay, so here we have ways that we can specify circles, and I've got lots of different ways here. I've got the method where I actually label across, which is I think the best option if you can fit the dimension in. If you can't fit the dimension in, I like this method, but you might find that even that's getting a little bit hazy. I don't have enough room to actually fit in 2 lots of arrows and a little bit of a line in between, so you can use this pointer and lead a line method. For radiuses, it should always point towards the center line. We can sometimes, like for this object here, where it's not really a circle, but rather a cylindrical object, then that's a fine way of drawing it. We should also nest our dimensions. I've talked a lot about this in my dimensioning videos in Stream or in AutoCAD, but just to quickly remind you, the minimum we should go is 10 millimeters, and then if we're having dimensions within dimensions, we should use, we should go out another 10 millimeters. They say in this document, in the VCE document, that you shouldn't have more than 2 dimensions stuck together. You should be using the whole drawing. When we draw an arrow, the arrow should be 3 millimeters long and 1 millimeter wide. The dimension line should never touch the object. There should be a little line that sticks out past the arrow called an extender. I like to have a 1 millimeter gap and a 2 millimeter extender. I think that's pretty much everything with dimensions. I have the page numbers that you can look for that here. Hopefully that should already be on your page. Okay, so what are you allowed to take into the exam? Well, you're allowed to take in a pair of compasses, a protractor, set squares, circle templates, including isometric circle templates, which I've already mentioned previously. You're also obviously allowed to take a blue and black pen to write with. You can use a mechanical pencil. I would have called it a pacer. You really should be using HB for thin, dark lines. You can use a HB pencil and a sharpener for dimension lines and center lines. Again, you could probably get away with a pacer if you wanted. I mean, I've marked a lot of drawings that were done in pen. It definitely is going to upset the marker. Like, they're going to see that and they're already going to think, okay, well, this kid is not really trying. But, you know, definitely there are kids who get full marks who draw in pen. 2H pencil for construction lines. You should never erase those, or not unless you've made a huge mistake. An eraser, you're allowed to use a ruler, also known as a rule, more formally. A scale ruler is something you're allowed to use. Now, you might not be familiar with what a scale ruler is, so let's get one of those up. Technically, they're called a scale, and this one here is a good one. It shows 6 different scales. And the idea is that you can measure off a drawing by just putting the ruler at the right size. And so I used to use these a fair bit. What's really interesting is the ones that are to 141, so that they're good for photocopied pages. Anyway. Okay, most kids don't use scale rulers. Most kids just use, do the maths in their head. Engineers tend not to do that because it does lead to mistakes. You're allowed to bring in set squares. Obviously, I recommend Kent brand set squares. Buy the biggest one you can. Compasses. So compasses are really important, not just for drawing circles, but also for doing those development pieces that we looked a little bit at, but we're going to talk about it in greater detail in Year 12. Protractors for measuring angles, circle and ellipse templates, and an approved calculator. They're the things you're allowed to bring in. Okay, so this is an ellipse template. This one's not very good. We have these at school. They're the wrong size because the dimensions go from here to here, which is wrong. If you look at the Kent ones, the dimension needs to be... Can you zoom in for me? Copy image address. The dimension needs to be the dimension from here to here. If it's from here to here or there to there, it's going to be wrong. So the dimension needs to be from here to here. Otherwise, it's going to be wrong. So, you know, be careful when you buy them. Here's a video on how to draw those. I did also in my last stream, I showed someone else's document that had those as well. Circle templates can be really useful. The ellipse ones are really useful. These days also though, if you don't want to bring an ellipse template for whatever reason, then that's fine. You can just freehand. You're allowed. Remember, it's a freehand pictorial drawing, so you don't have to draw anything to size. If you just take your best attempt at drawing the circle, that's fine in the modern age. Okay, so my job today is not to talk about bolt standards. So I'm not going to talk about this now, even though I was talking about this in the 25th of August last year. So that's about when I feel as though it's appropriate to start talking about bolt standards. Okay, so here's where I talk about questions I often put in the first Year 11 task, where I talk about what letters can you draw easily as isometrics. And so these are things that I might give you as an exam question. So like if I said draw the letter E as a isometric drawing, that's something that's quite achievable. And I talked about which letters, if you wanted to practice, which letters are the sort of letters I would give you. This here I talk about half sectional views. I talk about the dimensioning standards again. So you can see that my section is a half sectional view. So the section line goes like that. You can make just another reminder to talk about how the top view has to be on top, the side view has to be to the side. They have to line up. This is the view from that side. If I stood on this object and looked from this side, that's what I would see. I talk about how freehand lines are okay. I'm pretty good at drawing freehand now. I mean, I've been doing it for a long time, 25 years. But feathering is not okay. You don't draw lots of little lines. Draw one line and stick with it. If you need to erase it, that's fine, but draw one line and draw it with confidence. Don't draw lots of little lines, right? Feathering is going to lose you marks. Okay, that's that drawing. So I think these are just examples of freehand drawings. Okay, and we're not up to that yet. Okay, let's have a look at this second video and see what we've got here. How are we doing for time? We're doing okay. Okay, so I'm picking up from Drawing Standards. Okay. Okay, so from here what we're looking at is another picture I've taken of the board, and it just talks about these same things again. There's a couple of key things I want to talk about. Let's see if I can... Oh, can't copy that picture because it's a drawing, it's a video. That's why the quality's not great. Let's see if I can find this picture. It should be in Facebook. Maybe an older class. Possible. Should be here. Oh, that's a shame. I don't know how I would have found it when I was recording this stupid video. Okay, let's have a look at what we've got here. So the key things we want to talk about, stuff that I've already talked about. I've said here the gap from the object to what you're dimensioning should be 2 millimeters. Remember that the VCE document says 1, 1's probably correct. Then the extender line is 2 millimeters, the arrow should be 3 and 1 millimeter wide. That's what I'm specifying here. If you want to have two of them, two nested objects, then it should be 20 millimeters apart, right, rather than 10 millimeters apart. I'm talking about how you draw with a 0.5 HB lead. Don't draw at an angle, because if you draw at an angle, it starts off being much smaller and then it gets bigger and bigger and bigger and bigger. That said, if you pay attention to it, you can kind of control your lines. This is me talking about how you draw the arrows. So how you're supposed to draw the arrows. I tend to draw my arrow like, I don't know if you can see my arrow here. Let's hope that you do. I draw it from the top down to the line and then keep going down. What you're supposed to do is you're supposed to draw the line from the join, from this intersection out and intersection out. That's how you're supposed to draw it. I will say that professional engineers, they draw their lines up in this top corner. You can see this blue line, and they just draw the line across, and then they just draw a 45-degree line at each of the intersections. That's how professional engineers do it. I tend to do that, but because it's just very, very fast. And as long as people know what you're doing, it's a reasonable convention. If you can't fit the dimension inside the dimension lines, you can draw the dimension outside the line, which is what's going on in this corner here. Okay. Just getting a little paranoid that I'm just going to check that this is actually going out. 8 viewers. You're live. Okay. If anyone's watching this, by all means, please let me know. Oh well. It is or it isn't at this point. Okay, so center lines should be thin, dark chains. Chain is the technical term for this line, which goes long, then a gap, then a little dot. Let me just show you that back here. So the terminology we use for the line type, this is called a chain, and that's specified in the Australian standard as well. I'll show you where that's specified. I'll do it now. Okay, so line types are specified. I talked about this in my last video as well. So when we're drawing thin dashed lines, they have specifications. The gap needs to be a minimum of 1 millimeter. The length of the line can be 2 to 4 times the size of that gap. That's the specification. For a chain, the gap needs to be a minimum of 1 millimeter. We have the little gap, which we call Q, can be 2 to 4 times the size of the gap, and then the long one can be anywhere up to 10 times the size of the little gap. So that's where that specification is. So cutting planes is specified with thick, dark edges. I didn't know that until I saw it in a HSC question. In terms of sizes, our headings should be 2.5 millimeters if we're drawing in an A4 to A1. When I was a professional engineer, we did all of our drawings on A1. Titles should be 5 millimeters, subtitles should be 3.5 millimeters. So it's like a text that for, say, front view, top view, that should be 3.5 millimeters. Okay, moving back to our document. So that's where me specifying. I was saying here 4 because when I was at high school, we used to say that you can't really specify 3.5 comfortably. So they used to say 4 millimeters tall. I'm quite okay with 4 millimeters tall. The thing I really want to focus on in this drawing here, the side of the brick, is you'll notice that I've dimensioned all 4 sides of the brick. And when I've done that, the rule is that dimensions, I'm going to show this because this drawing here is much, much nicer than my drawing, that all of the dimensions are drawn above the line or to the left of the line. So if we have a look here, the dimensions here are written above the line, but do you see how I've got a line and it's drawn to the left and this drawing is drawn to the left. Now the Australian standard does say that you can actually dimension in the middle of the line. Don't do that. In the HSC, always draw above the line or to the left of the line, right? There's all different ways that people can help you remember it. Something they say is you should always dimension in the direction that if you were to hold the paper by its staple. And if you held the paper by its staple, let gravity fall and then read upwards. Look, that's fine, that works, but I just like the idea of, so the writing, if you write the number 4, the 4 should point to the staple. I just want to say though, I like the idea of, it's just so much easier just to remember to the left, right? Like Beyonce, everything in your bag in the box to the left, everything that you own in the box to the left. That's how I think you should do it. Just showing here, just to prove that, again, all the dimensions are above the line or to the left of the line. And they're always written as if they're, on top of the line. Okay, so that's that specification there that we've spent a lot of time talking about. I'm sure I mentioned all of this in the other video as well. Probably way better with lines that move around, but okay, so this is me talking through the drawing standards, saying you can buy ellipse templates. Okay, for threaded sections, we're not ready for threaded sections. That's you can watch that as additional content, that's fine. But so sectioning is probably getting this sort of sectioning here. Okay, we are going to talk about this now. Okay, so if we go to, keep going down this drawing. Okay, got drawing standards, lettering standards. Okay, sectioning. So we've already talked about sectioning a little bit now. We've talked about the apple and the capsicum, all those sorts of things. We've talked about, so here we have some counter boring and counter sinking. What we want to look at here is what the Australian standard says, that we should always try to go through the circles, even if they don't cut through a halfway line. We should do that by doing what we said before was an offset section. The angle of the line, I like to have my spacing much closer to this spacing than this spacing. I like big lines. Big lines are much less likely to go wrong in the HSC. When we go back to class, I'll show you how to draw these lines with a set square. There's a very fast way of doing them. But the idea is that if you're going to combine, always choose an angle that makes sense, right? You don't want to have an angle that's ever parallel or perpendicular to the object. Choose something that makes sense. If you have two objects next to each other, then you should have your section lines go in the opposite directions. If you have three things in contact, well, you don't have any choice anymore. Now you have to do something different. So what they recommend you do is that you change the angle for the new object, or you change the spacing. Okay, so if we have two objects in contact, this is the correct method, that's the incorrect method. This is more about making sure that you have your lines be sensible, that they're not parallel or perpendicular to the object. Okay, we're talking about offset sections and making sure that we go through the interesting part of the section. And that's what we're looking at there. Remember that the Australian standard does allow us to section webs, but remember, don't ever do that in the HSC. Even though the Australian standard allows it, I wouldn't do it, right? You don't know the marker, right? The marker, maybe they're going to know, maybe they're not going to know. So here again, when we draw our object, we want to make sure that we do an offset section that goes through all the interesting parts, and we want to draw an object that looks like this, not an object like this. Okay. Here's how we dimension. So some of the dimensioning standards I mentioned before. Here's how we show our tolerances. So that HSC question we saw before, we write the tolerance all in one line, is the way that we draw the tolerance. Okay, so that's the correct way to draw the tolerance. I don't like doing this. We should always draw the line above the line, and ideally it should be above the line or to the left of the line. If the thing doesn't fit, we can fit it on the outside if the line doesn't fit. Okay, I don't like this method. Like I said before, we shouldn't use this method. We should rotate it to 90 degrees. Okay, so now we're getting back to threaded sections. We're not doing threaded sections today. That's what this part of the document is about. And we're done. Okay, so that's a fairly comprehensive look at dimensioning standards. I'm always a bit nervous about talking about this because there's a lot of content, and even when you sort of have a checklist to go through to help you to say what we need to learn, it's pretty wonky. Here's an example of that HSC question we looked at before where they want us to do a half sectional view. Here's the answer for that half sectional view. And then another example from the HSC. So that's the question. This is the sort of way that we'll give a question where they say, okay, this is a isometric drawing. We now want you to produce it as a half sectional view. And I think I talk about like the specific things that people said and what they got wrong, and to try and help out. And I gave a couple of things where I thought the answer maybe was, wonky or whatever. So I mean, this is now a full hour of content when we already had an hour of content earlier. We haven't done threaded sections yet, where we've only introduced that concept. But for the moment, we should be able to do a section drawing. We understand how to draw in different materials, and we now have a really comprehensive understanding of dimensioning standards. So I can now say that we've got that covered. We've also done a lot of drawing already on AutoCAD. So with that said, when I go to titanium, I should be able to start ticking off quite a few things. That's an hour, so I'm going to stop recording now. See you later.